So we look at the first example. This is a polynomial over polynomial, and you know that as x goes to plus infinity or minus infinity, the limit of a polynomial is going to be either plus or minus infinity. So this case is again, this is an infinity over infinity indeterminate form. And well, it's a good one. We can use L'Hopital rule. Well, you may say that, okay, I can factor out the highest power, I can cancel them. Oh, yes, you can do that, but that won't take us longer than this example, at least in this page. That's why I'm putting the first one and show you that L'Hopital rule may give you a little bit longer solution for some specific cases, but the important thing is that you can cover more general cases. So here, limit of x goes to plus infinity, derivative of numerator 3x squared minus 10x plus 2, in the denominator minus 9x squared plus 8x minus 1. And again, you get infinity over infinity. You can use L'Hopital rule. This is lim x goes to plus infinity. This is 6x minus 10 over minus 18x plus 8. Another time, you see this is infinity over infinity. I can apply L'Hopital rule again. And well, this is just limit of constant. Limit of constant is always that constant, and that is negative 1 over 3. If you factor out the highest power, that will work the same way. The second one, okay, now this is where you right away should notice that, well, I don't have any other way to deal with this limit. I can just try to find the limit of the denominator is infinity, limit of the numerator is infinity. Done. I don't have any trick to find this limit. But infinity over infinity, well, I didn't have any. Now I have L'Hopital rule. That's my one. And I can replace the numerator by its derivative, the denominator by its derivative. And I'll get a new limit. Try to find that. Okay, again, it will give me infinity over infinity. L'Hopital rule can be applied. This is e to the power x, the derivative of numerator, derivative of the denominator is just 2 as x goes to plus. X goes to plus infinity, e to the power x, e to the power bigger and bigger number, it will grow to infinity, but divide. If a number grows to infinity, half of it must grow to infinity as well. So this is plus infinity. The third example, as x goes to 0 plus, let's just have the graph of these functions. Those will show me how this works. Okay, for ln is something like that, goes down. Okay? It never passes the y-axis, so the y-axis goes like that. And cotan x, I will do it with the red one. It's just something like that. So this is cotan x. This is ln x. As x goes to 0 plus, you see that cotan x goes to plus infinity. Ln x goes to negative infinity. So my limit is going to have to be negative infinity over infinity. Negative infinity over infinity is, you have to deal with it as infinity over infinity. What we do, well, I bring my magic box and replace ln x by its derivative, which is 1 over x. Replace Cotan x minus cosecant squared x as x goes to 0. Well, 0 plus is the same. Now, for a second, you better to stop here and see that the denominator is minus secant. Cosecant squared is 1 over sine squared. In other words, I'm dealing with this function. If you don't, if you try to do what I did before, you will notice that you will get again another infinity over infinity. You have to apply L'Hopital. You will get another infinity over infinity. You have to apply, you have to apply. It will go forever and never stop. You will get infinity over infinity, infinity over infinity. But if instead of that, you try to simplify this guy, meaning that, well, multiply the numerator of numerator to the denominator of the denominator over the denominator of numerator to the numerator of the denominator as x goes to 0 plus. Now you have 0 over, okay, so better to write it down there. You have 0 over 0. These are good functions, and I can use L'Hopital's rule. And that will give me 2 cosine x sine x over -1 as x goes to 0 plus. And now you see that the denominator is a non-zero, and we have good functions. So this is quotient law. You know, so we have 2 cosine 0 sine 0 over -1, which will give me the whole thing as 0. So these were other examples of L'Hopital rule when we are applying to infinity over infinity indeterminate